In 1638, this fella known as Nicolas Steno was born in Denmark. Steno is considered the father of stratigraphy, and thanks to him we have the so-called Steno's laws, which allow us to apply relative dating on rocks. In this video I'll talk about these rules using a great game called Horizon Zero Dawn, where we can admire all of Steno's observations. There are 4 essential laws in stratigraphy. The first law, rule or principle is the law of superposition, which says that younger rocks are always deposited on top of the older ones. So in these rocks that Aloy is looking at here, we are able to know that the rocks on the top of the sequence are going to be older than the rocks located at the bottom of the sequence. This may sound simple, but it defines geologic time, and it wasn't until 1669 when this was first described. If we were to find fossils in these rocks, the ones found at the top will be closer to us than the ones found at the bottom. And this rule is also applicable to other materials, such as lava flows. The second law of Steno is the law of original horizontality. Now, there are several exceptions to this rule, but it's fine to assume that beds are originally deposited flat in a horizontal position. As you can see here, all the beds are horizontal, meaning they follow the second law of Steno, one on top of each other. But hold on. In the game we may find beds which are tilting, not horizontally lowered. What this is telling us is that they have been affected by later events, which have disturbed their original horizontality. These events include tectonism or volcanism events, for example, which have the power to fold and change the topology and geometry of these layers. This is of extreme importance on knowing the history of the Earth, allowing us to know what has happened in the past. These beds, for example, have been affected by other external forces because they have a larger and different degree of tilting. And even sometimes, originally deposited flat beds can be completely vertical or turned over. The third law of Steno is the law of lateral continuity, which says that layers are continuous over the surface of the Earth until a body blocks them. We can see this very clearly in this area, where the layers can be continually followed all over the shores of the lake. This is of great importance on knowing erosion events, allowing us to relate layers which are disconnected because a river, for example, has removed them. Outcrops might be separated by large distances, but knowing that they once formed a continuous layer allows us to find them in other areas. In this canyon there are some very good looking beds over one of the sides of the valley. They are horizontal, and we know that some of them are younger than the other. If we apply the law of lateral continuity here, we will be able to know that the rocks that we find on the other side of the lake, which are very similar to the ones we just saw, are the same ones. This process is what we know as correlation. The fourth and last law of Steno is the law of cross-cutting relationships. This can be applied to all geology, and it states that any geological feature which cuts across rocks is always younger. For example, when a dike or a fault is cutting through a bed, it means that the bed is older than such a dike or a fault. So consider this outcrop. These layers were originally continuous, as we know, but now they are kind of cut by some kind of fracture. If we apply the fourth law of Steno, we observe that the fracture is continuous, cutting through the beds. This is telling us that the beds are older and the fault is younger. So alright, I hope this video has been useful for understanding geology a little bit better. Video games are full of these examples in these so-called increasingly more realistic open world games, which make an increasingly better geological adaptation, of course. So enjoy your geogaming and I'll see you in some other video.